Hi guys, everyone out there. So myself, I'm Praveen Tiwari. Today I'm your instructor for your cloud computing and AWS demonstration. So before starting this demonstration, I would like to give a brief introduction about myself. So myself, I'm Praveen Prasad Tiwari. I have pursued my Master of Computer Applications. I have 7+ years of experience in Linux administration and 3+ years of experience in AWS services. I'm currently working as Cloud SME with Controllers Tier 4 data centers in Hyderabad. I'm passionate about sharing the knowledge and learning and diving into the innovation of technology concepts. I'm always reachable at my email ID praveentiwari.techtrainer@gmail.com. So please do not hesitate to reach me out for any queries or clarifications or any discussions. You can post me at my email ID. So this is all about NINT. So we are based in Chennai and we are ISO certified organization established in 2012. We are good in IT software and hardware training to our customers to ensure always about customer satisfaction. So most of our training programs were instructor-led classroom and training, online training as well over the internet. So we do have a equipped qualified technical team to meet the objectives of yours. So our mission is always to exceed the expectations by providing the high quality and cost effective education. So this is our today's agenda. We are talking and discussing about cloud computing architecture, fundamental cloud services, deployment models, and introduction to Amazon Web Services. So what is a cloud computing? So everybody is talking about the cloud computing in this generation, current generation. Why do the people or the companies or the big organizations or medium scale or small scale or large scale organizations all are going for the cloud computing? Why do you think so? So what happens with this cloud computing? So what is generally cloud computing? So in order to understand this, I would like to take the best example of electricity services. So just think of electricity services. So what you are going to do with electricity services? You just simply plug into vast electrical grid managed by experts to get a low cost, reliable power supply available to you with much greater efficiency than you could generate on your own. So here we are using power. Power is a utility service available to you on demand and you pay for what you use. Let's take an example of your electricity appliances like your air conditioner, your refrigerator, your washing machine, your TV, television. So these all you need to pay only when you do use it. Unless you use this, you're not going to pay any current bill or electricity bill for those appliances. So similarly here, just think about this electricity services in a common manner for cloud computing. So cloud computing is also a utility service which is giving you access to technology resources managed by experts and available on demand always. So you can simply access these services over the internet with no upfront cost and you pay only for the resources you use. This is very major and very important thing about cloud computing, guys. So just always remember cloud computing is that you can access all the services over the internet with no upfront cost and you pay only for the resources you use. So what is this? That is about the cloud computing service. So if anyone asks you like what is a cloud computing service, just you can say like the services and the solutions that are delivered and consumed in a real time over internet are called cloud services. You can also take a best example like for example, if you want to store your photos online, you will use webmail or you can use social networking site. So you are using a cloud computing service over there. So that's the best example. So cloud services is nothing but it's a delivery model of computing services over the internet to keep it in abstract. So Gartner also reports that cloud computing is one of the top 5 technology trends in IT industry. And I think like you all are aware of the Gartner. Gartner is nothing but it is a delivery technology research to global technology business leaders to make informed decisions on key initiatives. So why should we go for cloud computing? So we always like to prefer to go for a best. If you like to buy something, you will always prefer for it. It should be a good one. It should give a major benefits for you. So there's all the factors you consider about it if you want to go for any purchasing anything. So similarly here, the people why they are going for the cloud computing is because they are having many attributes and major characteristics behind this. The attributes of this cloud computing are like they have no capital expenditure. As I said earlier, like you can pay as you go and you can pay only for what you use. And there is a true elastic capacity. True elastic capacity is nothing but you're scaling up and scaling down. Scaling up and scaling down in the sense like when you want to launch your instances, you can scale up, and when you do not want to require it anymore, you can just scale down. So also like you also get an opportunity to get to focus your engineering resources on what differentiates you versus managing the undifferentiated infrastructure resources. So here you only think about the resources what you require for you as per your circumstances and situations, and you do not require to think about the resources which you're not going to handle from your end. So guys, so that is about the cloud computing. So I think we are good to go further on this now. So this is about cloud computing architecture. If you see this cloud computing architecture, we do have three types of cloud computing over here. There is nothing but your infrastructure as a service, IaaS, platform as a service, PaaS, and software as a service, SaaS. So here in the types of cloud computing, why do we need this? Why should we know about these cloud computing types? Because this is very important for us to understand about the types of cloud computing so that it provides all the various departments like developers and IT teams with an ability to focus what matters most, and they can avoid undifferentiated work like procurement or any capacity planning or any kind of maintenance. So in any organizations, we do have the different groups and different teams, like for example, HR team or finance team or system admin team or IT team or Windows team or administrator group team. So we'll be having different kind of teams, right? So the major reason for this to segregating into different teams is to make the complicated work into very easy and very flexible so that we can divide the work as per the teams and they can work along with it and they can break into small modules and they can accomplish it in an accurate manner. So similarly here, they have divided these types of cloud computing as an IaaS, PaaS, and SaaS. So this cloud computing, each type of cloud service and deployment method provides you with different levels of control, flexibility, and management. So understanding differences between IaaS, SaaS, PaaS helps you to understand what deployment strategies you can use, which will help you to decide what set of services is right to do your needs. So let's start about with IaaS. So what happens with this IaaS? IaaS is infrastructure as a service which offers capacity for rent, basically hosted data centers and servers. So for example, if I want to host my 10 to 15 servers in a data center, or if I want to have web hosting for my websites, so immediately I would reach for any web hosting service provider like AT&T, or I would be reaching out for GoDaddy like that for the website maintenance, as well as if I want to maintain any servers like 15 to 20 servers or a couple of servers, I would reach for any data center or I would reach for any service provider to maintain those servers at his end. So in a similar manner, so what happens here is IaaS is providing you the capacity for maintaining your servers and or data centers. So it contains building block for cloud infrastructure and typically provide access to hardware features, computer, whether it might be a virtual or dedicated hardware, and data, and it is also providing a data storage space. So IaaS provides highest level of flexibility and management control over your IT resources. You can take an examples which would be mentioned over there, like rack space hosting, cloud services, and Amazon Web Services. So these are the best examples for the IaaS. So here you can see like what will happen in this IaaS is everything comes under in the same bundle of platform that is ready to rent. We can rent for all the machines which have been hosted in the data center. It also provides a compute. It also provides the storage, including with the network storage as well. So this is all we are getting through IaaS. So the best example, as mentioned over there, is Amazon Web Services. So Amazon Web Services, we are using it as a platform for getting all these things done. You don't need to run everywhere to get your work done. So what happens is like, so let's say for example, like the people might have a question, like why should we go for a cloud? Why should I not maintain my own infrastructure at my physical setup? So what happens in the business factors is like, so currently in the industries, what happening is, if let's say like I'm maintaining a physical setup of 15 to 20 servers. So there what happens is like the customer is happy with the 15 to 20 servers which right now we are maintaining. So the later the day goes on, like a couple of years goes, the customer comes and say like the websites are getting the performance is not up to the mark. So the customer want us to increase the performance of the servers by giving a more hardware capacity, and also they like to which suits their requirements of their applications. So the customer comes and say like there are many end users increased for the customer end, so they want to increase the number of servers from 10 to 150 or 200. So it gives a very hectic activity for us, since we need to get all the hardware license informations, and we need to get a patching management, we need to do configuration management for all of our servers. So it takes a lot of time for us to build all those servers and getting the hardware license. We need to segregate all the things, and we need to follow up, and we need to get the things done. So it takes a long time for us to build this physical setup. But whereas for the cloud, what happens is like they provide a single platform for all the things. If you want to build an instance, Amazon Web Service will be providing its hardware. Amazon Web Service is also providing its network. It is also providing this a block storage for the instance. It is providing all at the same place. So I no need to go and run for everything for everywhere else outside the AWS Web Services. So that's what I think it would be a clear example as an infrastructure as a service. So now let's go to PaaS, that is platform as a service. So platform as a service is nothing but it's a hosted application environment for developing or deploying cloud-based applications. So what this PaaS does is it removes the need for organizations to manage underlying infrastructure. It always allows you to focus on the deployment and management of your applications. So you don't need to worry about your capacity planning or software maintenance or patching, etc. So this has all been taken care at IaaS. So here in the past, you just only need to focus on how do you deploy your applications and how do you manage your applications. So there comes the best example of force.com and Windows Azure. Guys, I just want to make very clear over here, like Windows Azure is just an application name. We do have Microsoft Azure, which is different than this Windows Azure. So Microsoft Azure, again, it comes under infrastructure as a service. But whereas a platform as a service, you can only think about force.com or Windows Azure or Amazon EC2 instances, all comes under this platform as a service. So platform as a service, nothing but guys, just it's like providing you a platform to just manage your applications. You can create and deploy your applications in this PaaS. So let's now go to the next one, that is software as a service. So software as a service is like its most known and first service of the cloud computing. So software as a service it's an application provided by the service provider. So what happens here is SAS provides you with a complete product that is run and managed by service provider. So here you no need to think of how service is maintained or how underlying infrastructure is managed. Like let us take a best example of your webmail, like for example your Gmail or Hotmail or Yahoo or Rediffmail, any kind of applications of your email applications. So what happens over there? You just use your mailbox only to send your mails or receive your emails or to store any files or images kind of thing. So you're just using the application which is provided by the third party service provider. That's it. You no need to worry about how this Gmail infrastructure is underlying or how it is being managed. So just using the application as an end user. So that's what I want to make you very clear about, guys, regarding this IaaS and PaaS and software as a service. So just to make sure, like software as a service is nothing but it's like a ready-to-wear inbuilt application provided by your service provider. So you can use these applications available, which are available over the internet. So this gives you a clear picture of fundamental cloud computing services, SAS, PAS, and IaaS. As I said like earlier, like SAS, it's only the applications which are provided by the third party vendor or service provider, and we are using those applications at our end. That's it. So we are being over here just as end users and using those applications to receive your email or to send your email or to upload your photos or upload your images, save it in the Google Drive or any other Hotmail Drive, anything. So coming to the PAS, as I said, like it's only for deploying your applications or managing your applications. It might be any applications. It might be related to your security identity, or it might be related to your application integration workflows, or any user interfaces services, or database grid, or anything it might be. And next, coming to IaaS. So here it gives a very clear picture. So here we are maintaining our virtual machines, the virtual storage, virtual network. So basically we are doing all the administrative services part over here, like configuration management, scaling, lifecycle management, user management, packaging, etc. Those all things comes under IaaS. So here again it gives a very clear picture like how this cloud service end user it will be gives a clear visibility. So as an IaaS, mostly the system administrators or network administrators or IT infrastructure engineers might be using this, as this is the work will be based completely on the infrastructure part. And next, PAS, most of all software developers or application developers or software engineers will be using this PAS services. And as an end users, we all like we can use Gmail or Hotmail. So all the end users who use the application provided by the service provider will be considered as end users. So this is about cloud computing user perspective. Here you understand by seeing the few examples of applications which we can run under all the services like IaaS, PaaS, and SaaS. So all have its own benefits. So and all are very secure. Like say like IaaS, we use, as I said, like for hardware, virtual machines, network storage, everything we get at the same point of platform. And it uses secure infrastructure for a flat monthly fee. So you don't need to worry about your cost factors over here, about your cost expenditure. So there would be no maintenance cost, and you can scale up and scale down the amount of data storage. So it's just like pay as you go model. So and PAs, the same benefits you have, like here for example they have given like they are maintaining their system programming languages and web servers applications over here, and it also provides a benefit of you can use this secure cloud platform to develop and run your software solutions without the cost and complexity of buying and managing hardware and software layers. So here like it gives a very clear idea, like you you don't need to worry about the complexity of your hardware and software, because already it has its own applications and it's provide its own layers of those applications. So you can use those existing applications to make you reach the objective of meeting those to your infrastructure. So SAS, as I said, application software, your Gmail or Hotmail, you don't need to worry about its server maintenance and development cost. You're just using it for your purpose of sending emails or receiving your emails and updating your files in that, or storing your files in a Google Drive example. So that's it, guys. I think you're pretty very clear about it, like cloud computing, about this, the three types of cloud computing as well, of IaaS, PaaS and SaaS. So this is what the cloud computing service model looks. Infrastructure as a service, platform as a service, software as a service, the levels of abstraction, and how flexibility we would feel to control all over these services. So now we are going to discuss about this deployment model. Deployment models are nothing but they are providing here different types of clouds, like we say, like public cloud and private cloud and hybrid cloud as well. So here in these differences, like we need to understand like basically like what is a public cloud and what is a private cloud in this slide. So let's think about like if you want to if you want to maintain multiple instances on a shared basis, you can go for a public cloud, and it is hosted and managed by the cloud service provider, like for example your AWS or your Rackspace or your HP cloud, anything it might be. So this public cloud provides lower upfront costs, and it also simpler to manage, and it also offers high efficiency, high availability, elastic capacity. So the reason over here they mentioned this diagram is like, so we can use the combination of SAS, PaaS, IaaS as a combination of these whole three types of cloud computing in a same cloud, in the same public cloud. So public cloud is nothing but it is open for all the outside network. So generally what happens if you want to make sure like your employees need to, your employees can log into your any portal from outside the network as well, from your office network as well, then you can able to provide this public cloud. So let's say like if you want to access my login portal, I can go to the home and I can also log into my home. I mean I can log into the portal from my home as well, so that it provides some flexible and ease of access. And while coming to the private cloud is nothing but it's exclusively used for in a single organization, and it is managed by the in-house IT of those organizations. And for large number of applications, we may prefer this private cloud. So in private cloud also, guys, you can see over here, like we can use a combination of SAS, PaaS, IaaS, and the users will be able to access through private network. So what happens here is, let's say like we are having an organization and we do not want to disclose about our financial data to outside the network or to outside the employees. It should be restricted only to our internal employees, and it should be only, the link should be only available for the internal organization employees to access the data. So here what I would do is I would build those data, or I would build those servers in the network of private cloud, so that the instances will be accessible only through the office network, and it can't be accessible through public network. So this private cloud also provides lower total costs, and it also provides easier integration and greater control over security compliance, and it provides a quality of service. So here you might have a general query or doubt for the people, like why should I go for a public cloud if there is no security? Guys, it doesn't mean like a public cloud is not completely secure. It all in the cloud computing, we have to, how we design and how we manage and how do we deploy our application is the most important factor. Because let's say like for example, if we take an SSH port number, so SSH port number for the instance is 22. So if the port is open globally 22, so that any of the hackers or any of the people can log into their instances, can log into our instances using the port number, default port number 22. So it's not a good. under security compliance. So in order to restrict these kind of things, or these, in order to overcome this kind of situations or circumstances, what we need to do is cloud computing, like for example AWS is providing an opportunity or a feature to customize your port number for your SSH. Let's say if I build an instance in public cloud, and I don't want to keep port number 22, and I would define my own customized port number for my SSH, yes, you can define it, so that it would be restrictable for all the users to hack into your machines or to log into your machines to break your machines. So that's what you can customize everything in the cloud. It all depends on like how do you manage and how do you deploy your own infrastructure. And whereas private cloud, yes, so the difference is like in the private cloud, the cost will be very low. So why would be the cost will be very high in public cloud? It might be a question for you people. So the major difference over here is, like for example, if I am maintaining a server, I would get a large amount of data, and I want to store this large amount of data in a S3 bucket. S3 bucket is nothing but it's a simple storage service. It's a container thing. It's just like in your Dropbox application, which you use over the internet, where you can store your files until to the limit of extension they provide in the GB or TB something. So you're going to save all your files over here in the S3 bucket. So I would want to store over it through public. So what happens here is, if I'm storing it directly through the S3 bucket from my server, so it happens like it goes through public, right? So if it goes through public, there would be the charges would be very high, because the network connectivity will go from my end of server to the AWS S3 buckets. So all the network, the which is going throughput out, and what and all the how many files I'm storing over there, and all the charges would be applicable for it. So for all the sent out requests, the charges are applicable for it. The how much amount of data you are sending it, also the charges would be applicable for it. So whereas in private cloud, let's say it's like if you want to do the same scenario, so if you want to place your files, if you have your own private network and you're maintaining your servers and you want to place your files in S3, then the charges would be very less, because you're doing it through your private network. So also guys, just remember this thing, like whatever the things which you do through AWS and whatever the things which you do through public network, the charges would be high, and whatever the things which you do through private network, the charges would be very low comparable to public clouds. Yes, of course, private cloud, as I said, like you can maintain your own security compliance, which meets your requirements. As per your circumstances and requirements, you can deploy and you can design it. So what are the major cloud infrastructure service providers? So I think most of all are aware of it, like we all know about Amazon Web Services and Microsoft Azure and IBM Boomix and Google Cloud and Salesforce Cloud. So these are so in these, the major I would prefer and I would suggest for is only Amazon Web Services and Microsoft Azure. So the rest of the people who are maintaining the organizations and they are using for their business critical applications, or most of them with Amazon Web Services and Microsoft Azure. So the rest of the things comes to the next, like IBM, Boomix, or Google Cloud, or Salesforce. So here the people might have a question, like, why should I go for a cloud service? Why should not I maintain my own physical setup of servers? So earlier I took an example of like if I want to build large number of servers, like for example 15 to 150 or 15 to 200, then it would be a hectic task for me to get all the hardware license get done and do all the making any system configuration or patch management or making an setting up a life cycle dependencies on it. So to do these all things, it might take a very long time for me, as well as it also takes time for me to do a capacity planning for those and to make ensure that all are accurate. So in order to go for this, I can go for instead of this, I can go for AWS services where it is providing all the services like network, storage, computing, hardware, elastic block storage, your storage containers, your virtual private networks, along with your load balancers, routers, everything it is providing within a single platform. And there is also another example we can take, like for example, we do have this sometimes we do have a hardware failures, we do have a power failures for our machines. Let's assume like you are having a physical setup and you are having a production database servers. So if any production database servers, if there is any power failure on it, so how much it impacts? It impacts you very lot because the customer productivity goes down and the customer end users will start reporting to the customers that their websites are down. So when they reach to us, we check and found like, oh my God, the physical setup, the power failure is happening, and the power failure, you need to fix that. At least it might take around a 3 to 4 hours minimum. So that's what, in order to, instead of avoid these all circumstances, or in order to avoid these kind of problems, you can always choose for cloud computing services like Amazon Web Services. So Amazon Web Services, what happens is, if the same scenario happens in Amazon Web Services, like there was any power failure or there was any power failure in the data center, and your database server goes down. So we do have always have a clone copy for it. We can launch it in a maximum of 3 to 5 minutes. So within this 3 to 5 minutes, your instance will be stabilized and you'll get back to the same stable restore point of your server. So that's what, guys. I just want to make sure you all know about this cloud infrastructure service providers. So I would mostly prefer for Amazon Web Services and Microsoft Azure. So most what happens in the business critical applications and organizations is like if they want to go for more productivity, so they would think about the factors like high availability and scalable and durable factors. So in these cases, like they would prefer for cloud computing services of AWS Web Services and Microsoft Azure. So people, you might also have a question like, what are the if they are to what are the major competitors of Amazon Web Services? As per my understandings, Amazon Web Services is also having a one competitor is nothing but Microsoft Azure. So these two are major competitors in the market, Amazon Web Services and Microsoft Azure. There's a high demand for this both of the services, and there's a also a certification programs were going on for this Amazon Web Services and Microsoft Azure. So even the many organizations are looking out for certified candidates for Amazon Web Services and Microsoft Azure, so that it helps their organization to get many more business critical projects for their end. So now like we'll discuss about like what is Amazon Web Services, so what is AWS and why do we need to choose this. So guys, like Amazon Web Services are nothing but they are web services sometimes called cloud services or remote cloud computing. So first AWS actually it is they have started offering they have launched in 2006 to provide the online services for websites and client-side applications. Later, the market has grown rapidly increased, and they have also rapidly increased their services on day-to-day. And we do have many number of services offered by AWS right now. So here you can see in this graph, you can see like elastic and paper use infrastructure. So let's say like if you have a if you have a timeline of any infrastructure setup, you just need to first you need to think about its capacity planning, resource planning, and you need to do analysis, complete analysis for your dedicated traditional hardware. So what happens over here is you can see the large capital expenditure over here, how it is going on increasing for your infrastructure. So later in between you can see the actual demand of it. So the actual demand is still here, but the expenditure cost we have spent till here. So that's what. If you go with the physical setup kind of thing, like we can't estimate like how much it happens. So we need to make it prior, and we have to keep it. But even in between, if the resources are getting wasted, then it's like your wastage of money on your resources and also on your CPUs and also on your hardware capacity and storage as well. So guys, like majorly the people, why do they go for AWS is, as I said, like we do have four important factors which we need to keep in our mind so that the people should understand like why should we go for AWS. The first thing is durable, the first thing is scalable, durable and on demand, and also high availability and fault tolerance. So the first one comes as I said, on demand. So what is on demand? As I said earlier, like on demand is nothing but pay as you go model. So if you want to use your instances, you pay for it. And if you don't want to use those instances at that time, you can drop it down. You don't need to use about it. You don't need to bother about it. So that you can suspend it or you can terminate it or you can just pause it. So this what it gives a best example of a Wall Street app on Amazon EC2. So what happening here in this on-demand example? So let's say like we are having number of EC2 instances 300. So later on we need to increase our 300 to instances from 300 to 3000 instances. So what's happening in the weekend? If you see in the weekdays from Monday to Friday, everything goes good. So what happens here in on demand? You can see an example of a Wall Street app on Amazon EC2. So here you can see like we have a number of EC2 instances of 300. We have increased it from 300 to 3000. So later what's happening on the weekends? So the Monday to Friday the load is fine. I mean what and all the resources we have provided for the servers or what and all the capacity planning we have done for the servers is fine. But what happening on the weekends? You can see in the weekends like on there are most of our like 300 CPUs on the weekends are only getting utilized. The rest of all not being utilized. So what you can do over here is like if you don't want those instances, if you don't want to wastage your capacity or if you don't want to wastage your resources which you deployed and you're trying to manage, you can just suspend it or you can just stop it for your weekends through your automation process. So AWS completely also provides an automation of your auto configuring of your instances where you get an opportunity or a feature to launch your instances as you need and you can spin down your instances as you need. So here we think about the factor of scalable. So what's happening over in this scalable? So scalable here you can see like we do have major companies or we have major social networking sites like Facebook, we do have YouTube, or we have LinkedIn. So these are all three major organizations or major social networking sites are using AWS Amazon services. So here, have you ever seen the Facebook.com is getting down Or have you ever seen any maintenance page you're seeing on your Facebook page? Never, right? I didn't think like I have ever seen in my past years of experience seeing Facebook.com is getting down or Facebook.com any performance issues with it unless there is any issue with our network broadband or Wi-Fi. So here what happens, the reasons over here is like the reason to tell about this scalable feature is, let's say like we see a Facebook day to day it tries to create a new features. It also provides to create new services as well for the end users. So whoever want to use their services or if they want to use the new application features of Facebook, the people can use it. I mean the end users can use it. So what happens is they also scale their instances in the weekends or they might be they're doing it in the weekdays activities as well because it does not going to impact any productivity to the end users. So they will be doing their activities and the end users, as I mean like we the end users, we can also able to access the sites without any downtime or without any performance issues. So how is this going to happen? So what happens behind this? So let's say this example. So Facebook has done some modification in their application where they require 5,000 instances to manage that load of the servers from the end user's requests. So what happens is, so generally, if a new feature comes in Facebook or any social networking site or anything, we all as end users, we would be very enthusiastic or we would be very eager to know about the feature and we'll try to install the feature on our application or we'll try to use those features as our application in our application. So let's assume like there are many numbers of billions of users of Facebook over the world. So they would be always thinking or enthusiastic to understand this feature, and they would try to implement this feature, a new feature on their Facebook app. So what happens is, when all do at the same time, what happens? Absolutely, the load increases on the servers, right? So Facebook always scale to peak 5,000 instances in 3 days over here. So you can see they have launched many number of instances to manage the load on the Facebook servers, but it is not going to impact anything for the end user to use their services. And the next important thing about high availability and fault tolerant. So here we think about this high availability. The thing is like high availability is always provides you a backup of everything. Let's say, why are we maintaining backups? We are maintaining backups. If anything goes down, so we would be having a backup to restore it and provide a solution as a backup. So backup is always a solution for all the disaster things which goes very bad at the worst conditions. So here you can see like we are managing the backups in different regions. Like let's say on US East 1A we are managing the backups as well we are managing it in US West 1. So here this what happens. Like if anything goes down with one region, we would also have another region as a restore point for our instance. So you don't need to worry about it. So this gives a clear picture of high availability. So what is a fault tolerance? Fault tolerance is nothing but, let's say we have only one instance and if that instance goes down, then the customer site will go down or there will be a problem for the end users to access their websites and all. So let's say like fault tolerance is nothing but, let's say if you are having, for example, in a scenario, let's take two web servers. Two web servers. So in these two web servers are in the same region and all the web server requests are coming to these web servers. All the request hits in the sense like if they are using the website, they are trying to access, those all requests will come and hit to these web servers. So what happens over here is, let's say, unfortunately, one of our web server has gone down. So what would be happening? Obviously, and very clearly, we will also have another app server available to provide the requests. So meanwhile, what happens is, when one server goes down, so what load balancer does is, it only provides it only sends the request to the active web server, which is available, and another web server. I mean, let's say A and B, A has got down unfortunately. So all the requests will go to B and all the requests will be survive without any discrepancy. So that is about fault tolerance, which we have the future in Cloud Academy. I mean, of the cloud services. So here, like you can see over here, like a few terminologies of AWS, like Route 53, Elastic Load Balancer, CloudFront distributions. These all you can understand later on going on with the next concepts. So here, but for this session to make you understand very clearly, I just want to tell about this AZ, that is nothing but availability zone. Availability zones are nothing but they are just like in physical data centers. So how the infrastructure of this AWS happens, I'll show you in the next slide. So here, just for this terminology, I want to make you sure to think about it like Route 53 is nothing but your DNS, and Elastic Load Balancer is nothing but your firewall or router, and your availability zone is nothing but your physical data center. So now let's go to the AWS global infrastructure. So if you see this AWS global infrastructure, you can see over here like how they have designed this. So you can see there are many regions over here. We do have California, we do have Oregon, we do have UK, we do have Virginia, we do have Frankfurt, we do have Singapore, we do have Sydney, we do have Tokyo. So these orange ones are regions and number of availability zones, and these green ones are the new regions which are coming soon in the geographical locations. So we do have around like 48 regions currently, as per my knowledge, for the AWS global infrastructure. It's categorized into different countries. In different countries, we do have different zones. So what is these zones? Availability zones. AZs or availability zones are nothing but they are our physical data centers. So in one region, let's say like in US Virginia region, we do have East 1A, East 1B, East 1C, East 1B. So what are these 1A, 1B, 1C and 1D availability zones? These 1A, 1B, 1C and 1D are nothing but these are your physical data centers where you manage your host or where you manage your infrastructure setup. So in this global infrastructure, how they have planned this like, they have planned in a manner like in AWS US East 1A, for example, if I'm having in US East Virginia, I'm having 5 physical zones like East 1A, 1B, 1C, 1D and 1E. So there is a minimum of distance of 500 kilometers between each of the data center in the country. So let's in US East region, let's say we have 4 zones, availability zones, 1A, 1B, 1C, 1D. It looks like 4 are in same country, but the difference is like there would be a more distance, I mean like there would be a distance of 500 kilometers minimum in between all the zones available, I mean in between all the physical data centers in the region. So guys, just now assume like how much AWS is also managing and providing their services, how they are developing and managing the services for their physical data centers. If there are 48 regions, let's assume like 48, in each region there are around like 5 uh, physical data centers, which comes around like 48 into 5. That is nearly around 250 data centers, which nearly around 250 data centers AWS is managing all over through geographical location, and they're providing us the features of all the services which we use. So generally, this is the design which AWS follows. It comes up with the global infrastructure. Here you can see all the regions, availability zones, and edge locations. So edge locations are nothing but your caching. So it's just similar to your DNS caching. So what happens when you click any website on your browser? So the request goes to DNS server. In between, you will be having a DNS caching. So DNS caching will track all the history or track all the relevant information which you are requesting for, so that the next time when you click on the same request, it will gives you the information very rapidly. It gives you it provides you the information very fastly so that you can access it rapidly. So here, this what will happen here. Like if you are, let's say like if I'm based in Hyderabad or if I'm based in any southern part of the country in India, so I want to use my AWS web services. If I choose the region AWS Mumbai, India, they have launched it in the last year in India. The first place is in Mumbai. They have launched the data center. So if I'm using the data center from the Mumbai and if I want to host my missions over in the region of Mumbai, so the network access will be very rapid and it will be very fast for me since it is very near to me. So that was it happens like we do have different regions. So as per the customer needs, that we build their infrastructure onto their regions, whether it might be Canada, whether it might be a Singapore, or whether it might be a Europe or anything. So here if you see the foundation services, we have three types of services: foundation services, application services, and deployment and management. Foundation services is nothing but your EC2 instances, S3, EBS comes under it. Like EC2 instance, as I said, like it's nothing but just assume it like your computer or either it might be your laptop, something. And S3 is nothing but your simple storage service, a container for all your image. If you want to store your images or files or any kinds of objects over there, you can store it. EBS is nothing but your elastic block storage. It's also similar to your storage drive, like your hard disk or like your USB. So application services. So application services, you can see a few of the applications over here, like will be always available in the AWS library, like PHP, Java, iOS. So I don't need to go anywhere out to get these applications. It's already available in my AWS to make use of those applications. And deployment and management. So deployment and management is nothing but we would be having a management monitoring tools, like kind of thing, like if you want to track all the things what you're doing on AWS services, you can track it using the uh, CloudWatch. You can enable monitoring for your servers using this CloudWatch. For example, we do also have billing dashboard. Billing dashboard is nothing but if you want to see your expenditure and if you want to do cost optimization on your factors, if you want to reduce your cost optimization, and if you want to do a budget planning for your infrastructure, you can make it through this billing dashboard, which gives a very clear picture to you, like how much the budget is happening and how much it would be happening for the next coming months as per the needs of your infrastructure. So here you do have IAM. IAM is nothing but identity access management. It's nothing but your similar to your Active Directory in Microsoft Windows, where you can able to manage users and you can add your users to the groups. You can manage your users and groups, and you can assign some policies and roles for the users to perform kind of activities or restrict users to do some activities. So this all can do through IAM. So since this being just an introduction session, so we can see this complete very detailed about when we dive into the AWS management console about each and every service in a detailed manner. So this is all about our global infrastructure in the AWS. How do we use? So here you can see like it is providing all the applications. It's not only providing only few things. It's providing from all the cases of front. It provides for all the services for all the domains. You can see service applications over here. You can see the servers over here. If you want to launch it, you can take the load balancers. You can go for DNS, and you can go for messaging services. You can go for any identity access management. You can make your management console help to manage your infrastructure or manage your whole console. You can use CloudWatch for your monitoring. So all we are getting at the same point of thing. You can also use the cloud formation. Cloud formation is nothing but like if you want to build your infrastructure using the code, you can write a JSON scripts and you can build your infrastructure. For example, if you want to launch 100 instances at a time by using JSON script, then I make a JSON script and make it embed to this cloud formation, and the 100 instances will be ready in few minutes. So those many number of features this AWS is providing for us. So it's a very good ideal opportunity for us to learn about what services are on the AWS, and on day to day, as the days increases and the services are getting increased day to day, and the features what they are providing is also getting increased day to day on AWS. Let's quickly jump to the AWS console. So in this AWS console, I just want to make you show like how the things have been placed and how the services have been placed. So let's take this. So this like AC2 Management Console, Amazon Management Console looks like. So Amazon Management Console, AWS also provides you an opportunity for a new customers or for new users. It gives a free service for 12 months where you can able to access your machines, where you can build your servers without any cost. So there are only free tier servers over mentioned in the AWS, which provided by AWS. You can use it for your practice, or you want to make any demonstrations, or you want to make any practical things to get done over there. You can use this. And also the thing which I want to make you to understand about AWS here is like AWS charges every service which you use and every feature which you use in AWS dashboard over here. So it is like what you want to make sure or ensure over here is like whatever the instances you're launching or whatever the instances which you are setting up for your infrastructure, you want to make sure that you can see the cost optimization billing dashboard, and you can make sure that the things are proper and in the right manner. Let's say like if I'm going to the EC2 Management Console, so here is the thing you can see, it's my account. If you go to the thing, you can see my billing dashboard. So in this my billing dashboard, you can see all the costs over here, which is mentioned. I mean, like what is happening for your instances, or how much you're getting charged for your instances, what is the prices for it. So everything you can see over here. You can plan your budgets, and you can also do a payments using the payment methods available over here. You can also extract the reports of your billing for your management perspectives in order to plan your cost optimization on your infrastructure setup. So here in the services, yes, this was I want to show you guys. Like these are all the services you can see: compute, storage, database, network and content delivery, migration, security, identity and compliance, management tools, developer tools, analytics, artificial intelligence, Internet of Things, business, messaging, application services. So these are all the most services provided in the AWS, and day to day, sometimes AWS also will be increasing the more the features and services in every section over here available over here. So we should be up to date on that. So there might be a question like who are the what is the prerequisite or what is the eligibility to use this AWS web services as an end user? Yes, guys. So it's not mandatory that we should be a system administrators or we should be a software developers. We should be a management team members. It all depends upon the domain they work. Let's say like if you're a software developer or if you're a DevOps guy, then you can prefer only for the majorly for developer tools which you can use and make your automation. And if you are a management kind of guy, like if you want to only look for the cost optimization and if you want to reduce cost optimization for your organization and to meet your requirements, you can only see for the billing dashboard, and you can see the cost analysis, and you can make a proper planning and analysis on it. And as a database developers, like database engineers or database administrators, they are good to use this RDS or data or DynamoDB or the services which are available over here. And as a system administrator or infrastructure engineers or cloud architects or system architects, they would be using this compute and storage as an infrastructure as a part. So they would be having more activities on it. So this is what, like, it's not mandatory like you should be a system administrator or you should be a completely technical guy or you should be a developer guy or you should be a network guy or security compliance guy. So it's all about like learning. So it's very we should spend our ideal time to learn about this. So it would be very helpful for us to get up to date on each and technology concepts and the offerings which are being provided by AWS services. So guys, so this is about all up to this session. So I think it's pretty clear to you all like uh, about cloud computing and AWS services and about their offerings and about the private cloud and public cloud as well. So if you have any questions or if you have like to have any discussions, so please do not hesitate to post your questions or post your queries to email ID. I just would like to repeat it. It's praveentiwari.techtrainer@gmail.com. So we always believe like learning experiences or like journeys. The journey starts where the learning is now and it ends when the learner is successful. So we always, NINT would always like to ensure that you're grabbing some knowledge, you're grabbing some technology perspective of ideologies and you're returning it back. So nice guys, I think you have kept your valuable time for this. Thank you for you all.